Hello there, Mr. Sutton here, bringing you the IM3 Honors 1-4 Extra Practice number 3 solutions on inverse functions. There is a code breaker activity that goes with this one. Let's take a look at that. So here's a look at what the worksheet for this activity looks like. The idea here, as they explained, a message was scrambled and then encoded using the functions below. So we had a bunch of different letters that we turned into numbers using this alphabetical table. Then we plugged the numbers into these functions, and that gave us these numbers down below these blanks. Your job is to use your knowledge of inverse functions to figure out what these letters are, and then at the end of all this, we're going to have to unscramble each of these words to form a message. So that's the idea. Let's get going and see what the secret encrypted message could be. So our first function that we have to invert is this 5x plus 8 function. So to get the inverse, I'm going to switch my x and my y. So I'll rewrite this as x equals 5y plus 8. And then I just try to isolate y. So I can do that by subtracting 8 from both sides. So x minus 8. And then I'll divide both sides by 5. And I'll just rewrite y as f inverse. So I'm going to write f inverse equals x minus 8 over 5. What I'm going to do now is use my graphing calculator to come up with the plug-in values for this. I could probably do this without a grapher, but I want to show you that process now, just so you get used to it when we have bigger, more complex functions. So to do this on my graphing calculator, I'm going to go to y equals and just clear out whatever's already in there, and then type in this x minus 8 over 5. And I'll do alpha y equals and n over d to get a fancy fraction, just to make it look nicer and not worry about parentheses. So we have x minus 8 over 5. And the way that I am going to now plug these numbers into this, let me quit out of here. And actually, I want to go to table set. There's a sneaky way I have of doing this that makes it a lot faster. I'm going to go down to this independent part, and instead of having auto here, I'm going to arrow over to ask and press enter. Now what this does is when I do second graph and go to a table, it doesn't automatically populate the x values anymore. It wants me to tell it the x values to plug in. So I don't have to scroll down ever again. I can just plug in whatever random x value I want, and it'll immediately plug that into this function and tell me the y value. So let me plug in 33 first. That gives us 5. And then we'll plug in 48. That gives us 8. And then finally 108 plugged in. That gives us 20. So plugging those in again, we had 5, 8, and 20. Let me now go down to my table and see what those match up with. So 5, which is what we got 33 from. 5 is an E, so I'll put an E there. 8 matches up with H, so there's H. And then, let's see here, we got 20. 20 matches up with T, so there we go. So we'll be unscrambling that later. For now, let's move on to the next question and get some more letters. So for number 2, we're starting out with f of x equals radical x minus 3. Let me reverse x and y and rewrite this as x equals square root of y minus 3. Now to get y by itself, I have to get rid of this square root by squaring both sides. So I have x squared equals y minus 3. And then finally, let me add 3 to the other side to get y by itself. So we have f inverse equals x squared plus 3 for my inverse function. Let me put this in the grapher now. So just like before, I'm going to clear out what was already in there, and I'll write in x squared plus 3. And now, just like before, let me go to second table. I've already got ask mode set up in table set, so I can just go straight to table now. And I've got these values from before. I'm going to delete all those so I can punch in some new values. So what do we have for new values? It looks like, just moving my calculator a little bit, we've got 4.24. which comes out to about 21 if I round it off, and I have to round off for some of these. 2.45 is about 9. 2.83 is roughly 11. 0 comes out to exactly 3. And 3.74 we've got 17. So 21, 9, 11, 3, and 17. 21, 9, 11, 3, 17. There they are. Okay, so going down here now, 21 matches up with U. 9 is I. 11 is K. Haven't gotten one of those yet. They said 3 for this one, so that's C. And then 17 is Q. That's a number you're probably not going to be seeing too much. For number 3, we're using the function radical 4x. Let me reverse x and y, so x equals radical 4 times y. And now solving for y, I can square both sides, so x squared equals 4y. And then divide by 4, so we have y squared equals, or y rather equals x squared over 4. Let's put that in the calculator. So there's my y1, x squared divided by 4. Let's go to table now and plug these in. We've got 9.59, which is about 23, 8.49, about 18, 7.48 is about 14, 2.83 was about 2, and then 7.75, about 15. So here are those results again. Just write them down here. 15, yep. 23 went with W. 18 is R. 14 is going to be N. 2 is B. And then 15 was O. Here's my function for number 4, 4/7 x plus 6. Let me rewrite this now with x and y switched. So x equals 4/7 y plus 6. And now let's get y by itself by subtracting 6, so x minus 6. And then I'll get rid of this 4/7 by multiplying both sides by the reciprocal of that, 7/4. So I have f inverse equals 7/4 x minus 6. And notice I have a parentheses there. Let me plug this in the calculator and plug these numbers into it now. So here's my y equals that I'm showing you. I used alpha y equals n over d to get this nice little fraction mode here, 7/4. And now going to my table, we've got 14.57 plugged in that. Gives me about 15. 9.43 is about 6. And 19.71 comes out to roughly 24. So 15, 6, and 24. 15 is O, so there you go. 6 is F. And then 24 is X. That's a rare one. For number 5, I'll start this one by switching x and y. So x equals square root of 2y plus 1. All of that plus 7. I've got a few steps to get y by itself on this one. Let me first subtract this 7 out here. So x minus 7 equals that square root. Then I'll get rid of the square root. So just peeling an onion layer by layer outside, starting on the outside, working our way in. So I'll write this as x minus 7 squared equals 2y plus 1. I just squared both sides. Next up, let me subtract the 1. And then finally, dividing by 2, I have f inverse equals x minus 7 squared minus 1 all over 2. Let's go to the calculator for that. So here's what that looks like on the calculator using fancy fraction mode. Let's do second table and start entering all these in here. So 11.58, it's about 10. 12.75, it's about 16. 13.25 is roughly 19. And then we have 12.20, or just 12.2, comes out to 13.02. 13.56, my last scrambled number there, is going to be about 21. So we had 10, 16, 19, 13, and 21. 10 is J, 16 is P, 19 is S, 13 back here is M, and then 21 is U. For this next one, we have a cube root in the original function, which is kind of cute. So I'll switch x and y. We have x equals cube root of 9y. To get rid of all this stuff, I have to start by cubing both sides. So x cubed equals 9y, and then divide by 9. So I have f inverse x cubed over 9 going in my calculator. And here's what I've got in the calculator. X cubed over 9. Here's the exponent button in case you haven't used it in a while. Let's do second table now. Plug in 5.45. That gives me about 18. 5.13 is about 15. 5.83 is about 22. And then 3.56 gives us roughly 5. So 18, 15, 22, and 5. 18 is R. 15 is O. 22 is V. And then 5 is E. Rove, that actually spells a word. I'm not sure if that's the word they meant to spell, but it is one thing we could form with those letters. On to the next. This next one should be a pretty quick problem. It's just a linear equation here. So switching x and y, we have x equals 3y minus 7. So add 7 to both sides, and then divide both sides by 3. That's x plus 7 over 3. Now I could use the calculator, but really, do I need to? Negative 4 plugged in for x. Negative 4 plus 7 is going to be 3, and then 3 divided by 3 is just 1. So we have, that's A right there. And just to make my notation a little bit more clean, there we go. Just wanted to change that to f inverse instead of y. For this next problem, we're trying to get the inverse of 3 over 6x plus 10. So let's swap out x and y. We'll have x equals 3 over 6y plus 10. And then there's a few ways we could go to proceed from here. One thing we could do is flip both sides of the equation, and that would at least get y out of the denominator. Another way you could do this is multiply both sides by 6y plus 10 and then divide by x, effectively swapping those two things. So I'm going to rewrite this then as 6y plus 10 equals 3 over x. And then from there, I just have to get y by itself. So let me subtract 10 from both sides. And eventually I'm going to divide by 6, but it's kind of messy if I do it right now. So what I'd like to do is actually put all of this in one big fraction. To do that, I need a common denominator, though. So if I multiply this 10 by x over x, that is a good start. So we've got 10x over x. Now I can combine this into 3 minus 10x all over x. And at this point, to get y by itself, I just divide both sides by 6. When I divide by 6, it's kind of like multiplying by 1 over 6, which basically just puts the 6 next to the x in the denominator. So this is what I'm now going to plug into my calculator to run these different numbers. So here I am on the calculator. I've got this f inverse in my y1, and then let me go to the table mode here. I've already got my independent on ask, so I can just plug these numbers in. So we have 0.0188, press enter on that, 0.19, 0.037, and finally 0.0181. So that's giving me roughly 25, 1, 12, and 26. 25, 1, 12, and 26. What letters do those correspond with? Well, 25 is Y, so there's a Y right there. 1 is A, that one's pretty easy. And then 12 is L. And is this going to spell out Yale? Nope. 26 is Z, so it spells Yowls. We're going to have to rearrange that later on. But let's move on to the next problem now. For this one, let me start by swapping the x and the y. So I can write this as x equals 2 times radical y plus 5. And then to get y by itself, let me start by dividing both sides by 2. And then to unsquare root this, I have to square both sides. So x over 2 squared on the left side, and then y plus 5 on the right. And then finally, let's subtract 5 from both sides to get y truly by itself. All right, so let me plug x over 2 quantity squared minus 5 into my calculator. So there is the inverse function itself plugged into my y1. Now let me go to the table and just enter these numbers here. So 6.93, 6, and 8.94 gives me a 7, a 4, and a 15. 7, 4, 15. There we go. So 7 is G, 4 is D, and then 15 corresponds with O. So I filled in all the letters for the missing blanks there, but this doesn't really spell out anything sensible at this point. We're going to have to unscramble it. So my first word up here, E-H-T, T-H-E would be the, so I think that's the. And then this next one, this was a little bit tricky, but there's only so many words that have a Q in them. Probably starts with a Q, and then a U would have to come after. And if I put the I and the C and the K, that is quick. Then next, this one, let's see, B-R-O-W-N spells brown. And then not too many words with an X in them. F-O-X is fox, quick brown fox. That makes sense. And then J, if I do J-U-M-P-S, that's jumps. I can see a fox jumping. Rove is a word, but it's not, that doesn't make sense. The quick brown fox jumps rove. I don't know what that means. But over, it's almost in order. Makes sense. Jumps over something. And then is its own word. That was pretty easy. This one, not too many words with Z's in them, or Y's for that matter. If we do L-A-Z-Y, lazy, and then there's a few words I could spell here, but I'm thinking what the fox is jumping over is a dog. So the quick brown fox jumps over a lazy dog. This is actually a famous sentence that uses all 26 letters, the minimum amount of times, I believe. So anyway, till next time, Mr. Sutton, signing off.